Enthuse again. Well, people, this is going to be a third session of the Flash Drill series. Well, hit the chat box if I'm audible to visible to everyone. If I'm audible and visible to everyone, just hit the chat box with the thumbs up, guys, fast, so that I get to know whether I'm audible and visible to you or not. Wonderful. Everyone is saying Josh is high. Wonderful, wonderful, guys. Great, great, great. Okay. So in the last session, we talked about the limiting reagent concept, right? In the last session, we talked about the limiting reagent concept. And in the today's drill session, we are going to do few problems based on the same limiting reagent concept. Wonderful, guys. I'm seeing a lot of thumbs ups coming up. That means the Josh is actually high. Wonderful, guys. Great, great, great. Okay. Yes, Achut, it is live. It's live. Yes. I can read your chats, Achut. Yes, it's live. Okay, so before starting, as we all know, we are supposed to introduce ourselves. You might be knowing now, I'm Wassim Bhatt and I am your chemistry master teacher over here. Okay. Now, people, before starting, what are we supposed to do? We are supposed to like, share and subscribe, as I tell you in the every session, so that everyone gets benefited out of these lectures. Okay, so please do like, share and subscribe the channel at the same time. And people, talking about the schedule which we have been following from past many days, let's have a look on it again. In the first session, we talked about the terminologies involved in the mole concept. In the second session, we did the basic mole concept, the average molar mass of gaseous mixture as well. In the third session, we talked about the percentage of an element in a given compound and the stoichiometry, okay? And in the last session, yesterday, we did the percentage yield, percentage purity and the limiting reagent concept. And people, in now, what we are going to do is we are going to do some questions based on the concepts of the limiting reagents only, okay? And this is our third session of the Flash Drill series. Alright, so let's move ahead and let's talk about the questions which we are going to do over here. Have a look, guys. This question is on your screen. You can have a look. You can have a look on the question. Just give it a try. If 5 grams of each reactant were used for the following process, the limiting reagent would be. The reaction is given to you, and the reaction is given in the balanced form as well. What is given in the question? We are given with 5 grams each of reactants. We are given with 5 grams each of reactants, and we have to check which one would be the limiting reagent among these 3 reactants. As we have discussed in the last session, what is a limiting reagent? Limiting reagent is that reactant or that reagent which completely gets consumed in the reaction. Right? So we have to identify which one among the 3 is the limiting reagent. I'm seeing the answers. Okay. Great, Achut. Okay. Senadita has also given one answer. All right. So now let's try to solve this question. Let me show you how to identify this limiting reagent. Have a look, guys. Very, very simple concept it is. Okay. First of all, I'm given with the balanced chemical reaction, right? This is my reaction. Twice KMnO4. I'm writing it again over here. Twice KMnO4 plus 5 times Hg2Cl2, right? Plus 16 times HCl plus 16 times HCl. It gives 10 times. Okay, I have got nothing to do with the products, right? I just have to identify which one is the limiting reagent, right? So either KMnO4 will be the limiting reagent, or Hg2Cl2 will be the limiting reagent, or HCl is going to be the limiting reagent, right? Now, what is given in the question? If 5 grams each of reactants, first of all, I'm given with 5 grams of KMnO4, I'm given with 5 grams of Hg2Cl2, I'm given with 5 grams of HCl as well. Now, I need to identify which one among the following will be my limiting reagent. The process by means of which we check which one is the limiting reagent, that already I have discussed with you in the last session. I'm going to follow the same procedure by means of which we'll get to know which one is the limiting reagent over here. The first thing, we are given with the mass of the reactants. We are given with the mass of the reactants. The first thing which I'll be doing is I'll be converting the mass of the reactants into their moles, right? And we know how to convert mass into moles. We just divide the mass by their respective molar masses, right? So I would say at time t is equal to 0, initially when the reaction has not started, I'll be having moles of KMnO4 as, see, mass of KMnO4 is 5 grams divided by molar mass of KMnO4, all of you must be knowing, that is 158 grams per mole. So 5 divided by 158 is going to be the number of moles of KMnO4 initially with me, right? Similarly, number of moles of Hg2Cl2. I'm given with the mass, and you would be knowing its molar mass, that is 472 grams per mole, right? So how many moles of Hg2Cl2 I'll be having at time t is equal to 0? I'll write given mass, that is 5 grams, divided by molar mass, that is 472 grams per mole. So I have got 5 divided by 472 moles of Hg2Cl2 at time t is equal to 0, right? Similarly, talking about HCl, I have got 5 grams of HCl, so let's convert it into moles. It's going to be mass of HCl, which is 5 grams, divided by molar mass of HCl, that is 36.5. So these are the moles of the reactants given to me at time t is equal to 0, right? Now, in order to identify the limiting reagent, if you guys remember, what are we supposed to do? We are supposed to divide these moles by their respective stoichiometric coefficients, right? Just divide this term by its stoichiometric coefficient, that is 2. So I'll just divide it by 2. Similarly, divide these moles by its stoichiometric coefficient, that is 5. I'm dividing it by 5. Similarly, divide this whole by its stoichiometric coefficient, that is 16, right? Right, guys? So the one with the least stoichiometric ratio. See, what am I getting now? When I'm dividing these moles by their respective stoichiometric coefficients, what I'm getting? I'm getting the stoichiometric ratio, right? The one with the least stoichiometric ratio would be my limiting reagent. Just check it out. This one is having the least stoichiometric ratio, right? And that one, which will be having the least stoichiometric ratio, is always going to be my limiting reagent, right? So Hg2Cl2 over here is going to be my limiting reagent. What can I conclude from that? I can say Hg2Cl2 is going to get completely consumed in the reaction, and entire product will be decided by your Hg2Cl2, which is my limiting reagent over here. Wonderful, guys, wonderful. I'm seeing a lot of option D's are coming. Wonderful, great, great, great. So I'm sure this is clear to everyone. If this is clear to everyone, just hit the chat box with the thumbs up. Fast, guys, fast, fast, fast. Yes, Madhvi, absolutely, absolutely, absolutely. Just hit the chat box with the thumbs up so that I get to know the concept is clear to everyone. Wonderful, guys, great, 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 great. Wonderful, guys, great, great. Okay, so let's move on. Saurabh is asking, what is the use of limiting reagent? By using the concept of limiting reagent, we can calculate many things. I told you in the last session itself. We can calculate the amount of product formed, right? We can calculate how much excess reagent is left. Everything we can do that, okay? So let's move on to one more question, guys. One more question of this drill series, which is going to be this one. Just have a look on the question. Just try it out. Let me know the answer in the chat box. What mass of ZnCl2 can be prepared from the reaction of 6.54 grams of zinc with 3.65 grams of HCl? Okay, the reaction is given to us and the reaction is given in the balanced form. What are we supposed to calculate? We are supposed to calculate the mass of ZnCl2 that would get formed in the reaction. I'm giving you 30 seconds of time. Just try it out and let me know the answer fast. Okay, do it, guys. Mickey, I'm in Bangalore. Yes. Yes, Madhvi, I'll be doing that as well. I'll be doing that as well. Yes, absolutely. All right, so let's get started with this question, guys. Let's see what this question is all about. Again, a very simple question based on the same concept of the limiting reagent. Just give me a second. Okay. Have a look, guys. I'm given with the reaction. The reaction is simple. What is it? Zinc. I'm going to write it like this. Zinc plus twice HCl. It gives ZnCl2 plus H2 plus H2. First thing, what am I given with? Am I given with a balanced chemical reaction? Just check, is it balanced? Definitely this is a balanced chemical reaction. And while using the concept of the limiting reagent, what is my first step always? My first step always is to balance the reaction, and the reaction itself is balanced. It's given in the equation itself, right? What are we given with? We are given with the mass of what? We are given with the mass of zinc, which is 6.54 grams, and we are given with the mass of HCl as well, okay? We are given with the mass of zinc and HCl, okay? What am I going to do over here is, I'm going to convert the given masses of zinc and HCl into their respective moles, right? I'm going to convert the given masses of zinc and HCl into their respective moles. Now have a look. See guys, this 6.54 is the mass of zinc which is given to us, right? So number of moles of zinc would be equal to given mass of zinc, which is 6.54 grams, divided by molar mass of zinc, which is around 65.4, right? So how many moles of zinc I have in the beginning? In the beginning, I have got 0.1 moles of zinc. So at time t is equal to 0. Time t is equal to 0 means that the reaction has not started yet. The reaction has not started yet, right? At time t is equal to 0, the moles of the zinc are going to be 0.1. Okay, talking about the moles of HCl, we are given with the mass of HCl, which is 3.65 grams. Let's convert it into moles. So I'm writing number of moles of HCl is going to be, I'm given with mass of HCl, just divide this mass by the molar mass of HCl, you'll be getting number of moles of HCl. So number of moles of HCl is going to be given mass of HCl, which is 3.65 grams, divided by molar mass of HCl is 36.5 grams per mole, and I'll be getting the value again equal to 0.1. So I'm having 0.1 moles of HCl as well. So in the beginning, at time t is equal to 0, when the reaction has not started, I'm having 0.1 moles of zinc and 0.1 moles of HCl. Can I say the number of moles of ZnCl2 and H2 would be 0 at time t is equal to 0, right? Why is that? Because the reaction has not started, okay? Now people, in the last session I told you, whenever you'll be given with the amounts of all the reactants, at that time, which concept do we use? We use the concept of limiting reagent. And now it is the time to identify which one among the following is the limiting reagent. I have to check that, okay? Your zinc and HCl, which one is the limiting reagent? I need to check that. And how do I check that? By simple following the stoichiometric ratio, right? Have a look guys, have a look. This is my reactant, zinc. I have got zinc is my one reactant. Similarly, I have got HCl as another reactant. HCl is another reactant, okay? What is the stoichiometric coefficient of zinc? It is 1. What is the stoichiometric coefficient of HCl? It is 2. Correct? How many moles of zinc and HCl do I have? 0.1, 0.1, right? Now what am I going to do? I'm going to calculate the stoichiometric ratio. For that, what do I need to do? I just need to divide these moles by their respective stoichiometric coefficients. See, 0.1 divided by stoichiometric coefficient, 0.1 divided by its stoichiometric coefficient. Okay, now which one among these is the least stoichiometric ratio? This one is the least stoichiometric ratio, so HCl is going to be my limiting reagent over here, because we know the one with the least stoichiometric ratio is always our limiting reagent. So your HCl is going to be our limiting reagent over here. Okay, now guys, have a look. If HCl is the limiting reagent, can I say HCl is going to get completely consumed? And when HCl will get completely consumed, I would say the reaction will stop, and at that time I'll be left with the 0 moles of HCl, correct? And the entire product, since we got to know HCl is the limiting reagent, I would say the entire product will be decided by your limiting reagent, right? And what am I supposed to calculate in the question? I'm supposed to calculate the mass of ZnCl2. So what am I going to do is, I'm going to relate this HCl with this ZnCl2. Okay, so what should I say? I'll just use the stoichiometry. I'll just use the stoichiometry, right? Can I simply say 2 moles of HCl? Why am I starting from HCl? Because HCl is my limiting reagent and the entire product will be decided by the limiting reagent only, right? Okay, 2 moles of HCl gives 1 mole of ZnCl2, I would say. So 1 mole of HCl should give me half mole of ZnCl2. And how many moles of HCl do we have? We have 0.1 moles, right? So 0.1 moles of HCl should give me 1 by 2 multiplied by 0.1, or I would write it like this: 0.1 divided by 2 moles of what? Moles of ZnCl2, correct? So how many moles of ZnCl2 are getting formed? 0.1 divided by 2. Am I supposed to calculate moles of ZnCl2 or mass of ZnCl2? I'm supposed to calculate mass of ZnCl2, but what did I calculate right now? I calculated the moles of ZnCl2. In order to convert it into the mass, I'm supposed to multiply it by its molar mass, right? What is the molar mass of ZnCl2? Just have a look. Zinc is going to be what? Zinc is going to be just a second. Zinc is going to be 65.4. Chlorine is 35.5. So it's going to be 71 because I've got 2 chlorine. It's going to be 4, 5, 1, 6, 7, 6, 13. 136.4 is going to be the molar mass of ZnCl2. So I'm simply going to multiply this term. by its molar mass. What I'll be getting? I'll be getting the mass of ZnCl2. And let me tell you its exact answer. Its exact answer will be 6.92 grams. Just hit the chat box if you got the answer as this. Just hit the chat box with a thumbs up, guys, if you got this answer. Just tell me fast. That's great, Divakar. That's great. Nice to hear that. Wonderful, guys. Okay, let's move on to one more question. Okay, a very, very simple question. It is based on the same concept. Just tell me its answer fast. The same type of question based on the same concept, guys. The same type of the question based on the same concept. Just tell me the answer fast. Okay. Rishi is giving the answer, fine. Okay, Divakar is giving the answer, fine. Who else? Okay, Ashut is giving the answer, okay. You'll be getting the PDF in the Telegram group, guys. PDF you'll be getting in the Telegram group. Yes, absolutely. Okay, let's get started with this question, guys. It's again a very, very simple question. Have a look. How many grams of NH3 can be prepared from 84 grams of N2 and 15 grams of H2, right? Very, very simple question. First of all, you should know the reaction when N2 reacts with H2. It gives what? It gives your NH3. It gives the NH3, right? The first thing I'm given with the mass of N2, which is 84 grams, and I'm given with the mass of H2 as well. My first step is going to be to convert these given masses into their moles, right? So I'll be writing number of moles of N2 would be equal to mass of N2, which is 84 grams, divided by molar mass of N2 is going to be what? It's going to be 28, right? Molar mass of N2 is going to be 28 grams per mole. So the value will come out to be 3. Right? Very, very simple. I got the number of moles of N2 at time t is equal to 0. Understand properly. Number of moles of N2 at time t is equal to 0. I got as 3. Now similarly, at time t is equal to 0, I need to calculate the number of moles of H2 as well. I am given with the mass of H2, which is 15 grams. And what is the molar mass of H2? Molar mass of H2 is 2 grams per mole. So I can write number of moles of H2 would be equal mass of H2 divided by molar mass of H2. So the value would be 7.5. So at time t is equal to 0, I'm given with 7.5 moles of H2 as well. Can I say over here, the NH3 value, the number of moles of NH3 formed would be 0. But guys, I forgot to do one thing. Can you tell me what is that? I forgot to do one thing over here. I forgot to do one thing over here. Can you tell me what is that? Tell me fast, just hit the chat box, hit the chat box. I forgot to do one thing over here. Can you tell me what is that? I forgot to balance the reaction, right? So let's try to balance the reaction. This is 3 times, this should be 2 times. Now the reaction is balanced. Now the reaction is balanced. We have to check how many grams of NH3 are formed, right? I told you in the beginning itself, whenever we are given with the amounts of both the reactants, always at that time we use the concept of the limiting reagent, okay? And in order to identify the limiting reagent, my first step will be always to balance the reaction. The reaction is balanced, okay? Now it's time to identify which one is the limiting reagent, correct? See, I just have to divide these moles by their respective stoichiometric coefficients, right? This is 3 divided by 1, that is 3. 7.5 divided by 3, that will be less than 3. So I would say H2 is my limiting reagent over here. H2 is my limiting reagent over here. If H2 is the limiting reagent, I would say H2 is going to get completely exhausted. If H2 gets completely exhausted, so I would say when the reaction will stop at that time, the number of moles of H2 would be 0, right? Now people, I need to check what is the mass of NH3 that has got formed in the reaction, during the reaction, right? How do we do that? I have told you, your entire product is completely decided by the limiting reagent. So I'll be relating my limiting reagent with this NH3, as simple as that, right? So can I use the stoichiometry? I can say 3 moles of H2. I can say 3 moles of what? 3 moles of H2 gives 3 moles of H2 gives 2 moles of NH3, right? Three moles of H2 gives 2 moles of NH3. Now can I say 1 mole of H2 should give me 2 divided by 3 moles of NH3? Right? But how many moles of H2 I have? I have 7.5 moles. If 1 moles of H2 is giving me 2 by 3 moles of NH3, so can I say 7.5 moles of H2 should give me 2 by 3 multiplied by 7.5 moles of NH3. So I got the moles of NH3 over here. I got the moles of NH3. Am I supposed to calculate moles of NH3 or mass of NH3? I'm supposed to calculate mass of NH3. And how do we convert these moles of NH3 into its mass? I just have to multiply with the molar mass of NH3. Molar mass of NH3 is 17. So this value will be coming in grams. Okay, just calculate this value. This would be the mass of NH3 that would get formed at the end of the reaction. Okay, let me give you its exact answer, guys. Let me give you its exact answer. I hope you would have taken the screenshot of it, right? Let me give you the exact answer after the calculation. It is going to be 85 grams. So at the end of the reaction, I would say 85 grams of NH3 will get produced. Okay, very, very simple. Exactly, guys. Wonderful, great. Exactly, 85 grams, correct. So let's move on to one more. Let's move on to one more question and just tell me the answer fast. Just tell me the answer fast. Oh my God. Okay, this is a question, guys. Again, a very, very simple and basic question on the concepts which we have discussed till now. Yeah, exactly. All of you must be giving the option A. Yes, I get it completely. Yeah. Exactly. Yeah. Got it. I got it. Okay. Same question, same type of question on the basis of the concepts which we have discussed, right? See, guys. I'm given with one balanced reaction. And I'm given with the 2 moles and 8 moles. I'm given with 2 moles of C5H12 and 8 moles of O2 in the beginning. I have to check which is the excess reagent. Very, very simple question it is, right? I'm sure you would have killed this question. See, guys, have a look. See, I'm going to write the reaction again over here so that it gets clear to you. The reaction is C5H12 plus 8 times O2, right? I'm just going to write the reactants. Right? Because the limiting reagent is always among the reactants only, right? Now people see, the reaction is already balanced. The stoichiometric coefficients are 1 and 8. This is the stoichiometric coefficient. This is the stoichiometric coefficient of O2 over here. Now at time t is equal to 0, initially when the reaction has not started, how many moles of C5H12 are there? There are 2 moles of it, right? I'm given with 2 moles of it. And how many moles of O2 do I have in the beginning? I have got 8 moles of O2, right? I have got 8 moles of O2, correct? Now I have to identify among the two first which one is the limiting reagent, right? How do we do that? I'll just divide these moles by its stoichiometric coefficient. I'll divide these moles by its stoichiometric coefficient, right? The value over here is coming as 2. The value over here is coming as 1. So which one is having the least stoichiometric ratio? This one is the least stoichiometric ratio. So O2 is going to be my limiting reagent. If O2 is the limiting reagent, that means this one is the excess reagent. And in the question, what was asked? Which one is the excess reagent? So which one is the excess reagent? C5H12 is the excess reagent, as simple as that, right? Basic question based on the same concepts which we have discussed till now. Okay, I'm sure easily you can solve these kind of questions from now onwards. Okay, I have got one more last question for you. I mean, just tell me the answer, guys. Complete theoretical question it is. Just tell me the answer fast. Just tell me the answer fast. The limiting reagent in a chemical reaction is one that has largest molar mass, that has the smallest molar mass, that has the smallest coefficient, is consumed completely. You guys give me the answer. You guys give me the answer. All of you must be knowing, right? We have discussed the concept, correct? We have discussed the concept. Limiting reagent is the one which gets completely consumed in the reaction. And when one of the reactant gets completely consumed in the reaction, I would say the reaction would stop at that time. Okay? And if one is the limiting reagent, the other one is going to be the excess reagent. And your entire product is decided by your limiting reagent. I'm sure the concept of limiting reagent is clear to everyone. If the concept of limiting reagent is clear to everyone, just guys, hit the chat box. Hi Unita, hi, what's up? Just hit the chat box with the thumbs up if the concept of limiting reagent is clear to everyone. No, there are no differences in the content. Yes. Okay, I'm getting a lot of crystal clear. Thanks. Thank you guys. So this was all for the today's drill session, and let me tell you, in the evening session which I have at 5:30, I'm going to start one of the important topics which we call as concentration terms. Don't forget that. Okay, so at the end, this is the schedule again. Just have a look. In the evening 5:30 class, when I'll be coming live again, I'll be doing the concentration terms with you. Okay, and a lot of good questions will be discussed. Okay, and guys, this is the Telegram group which you guys are going to join in. Why is that? Because we always send the PDF notes in the Telegram group itself, and the PDF notes will be also given in the YouTube description link as well, right? But this is the Telegram group. Whatever information is there, about the class, you get to know about that by just joining this group. Okay, all right. And at the end, you all know, what are we supposed to do? We are supposed to like, share and subscribe the channel so that everyone gets benefited out of it. Okay, this was all for today's session. Hi Emin, what's up? How are you? Yurita, I'm doing wonderful. Hi Shri. Nazir, what's up? How are you? I'm doing great, guys. I'm doing great. Okay, I'll see you in the evening session at 5:30. Till then, take care. Bye bye. God bless you all and love you all. Bye guys. Take care.